Okay, I'm going to try this a different way. We're going to do a past paper. It's from 2024, May, June. Okay, and it's the 047821 IGCSE Computer Science paper. Okay, it's a long paper. It's timed for 1 hour and 45 minutes, and it's worth 75 marks. Okay, so paper 2, Computer Science IGCSE from 2024, May, June paper. Okay, this is version 1. Okay, so question 1. Tick one box to complete the sentence. A validation check to make sure that the email address contains an @ sign. Okay, an @ sign. Is a range check? No, because that's an amount. A visual check? No, visual check. A presence check? Could be, it's maybe think that. So the correct answer would be a format check. Why? Because a format for an email, format check, is generally and then the @ sign is in the middle, so there's something before, then there's the @ sign, okay, and there's something in between, something afterwards. gmail.com, for example. Okay, question 2. 4 descriptions of programming concepts and 5 programming concepts are shown. Okay, draw one line to link each description to the most appropriate programming concept. Not all programming concepts will be used. Well, they won't, because there's 5 of those and 4 of those. So, first of all, a subroutine that may not, is bold, return a value. Okay, well, the only 2 subroutines on here are function and procedure, and they're the same thing. Okay, so a subroutine that will always return a value, so not return a value, may not, and always return a value. Okay, well, the one that will always return a value is what we use all the time when we're defining something, is defining a function. But, in my mind, a function and procedure are one of the same things. But, in this case, I'll put a little bridge there. Okay, so that's that, 1 and 2. And then we've got these 2 others, a value that is declared and used within a specific procedure, keyword there. Specific procedure, that would be a local, okay, again for a bridge jump, a local variable. Okay, and then finally, a value that a procedure expects you to apply when it is called. Well, that's obviously going to be not a global variable, it's going to be a parameter. I mean, realistically, we could have done these in a separate colour, big bridge, okay? It's always good if we're doing this, if we put 1 there and 1 there, don't put A in the 2, okay, 3, and 3, and then finally 4, and 4. Okay, so you can do it like that. Okay, for 2 marks, write a pseudocode to use a procedure named average that passes the value 25 and 50 to the procedure. So looking through this paper, there's a lot of stuff about defining functions and procedures. So this is something, if you're unfamiliar with it, writing basically subprograms. Yeah, and I'm sure when we get to the final question, there will be a lot of work in terms of defining and creating subprograms. We're going to use something called call here, and I'm going to explain why. Okay, I'm going to try and find some space and explain why. So we're going to use call, and we're going to call average. Okay, we're going to call the average, and we're going to call 25, 50. Okay, so that's the answer. But write the pseudocode to use a procedure. This is what the procedure would be. Okay, we'll try and create the procedure. In this case, would be average. Okay, and this is going to be given 2 values. Value 1, value 2. So that's my parameter. Yeah, they're my parameters. Value 1, value 2. They're my parameters within this procedure. So going back up to what we had here, okay? Yeah, my parameters, a value that a procedure expects you to supply when it is called is a parameter. So we've got our parameters, yeah, value 1 and value 2. Let's make a little note of that. Parameters, okay? So procedure, average, value 1, value 2. Our parameters are in the procedure. Then I'm going to create a variable, a local variable, avval, average value, avval, yeah, and I'm going to assign that value, assign the value, value 1 plus value 2. Okay, so average val, my local variable, has been assigned a value, average 1 plus average 2. Okay, and then because it's an average, of course, we've got to divide the two values by 2. So that's going to be what we're going to do. This is part of the procedure. And then we're going to output. Okay, we're going to output a message. So output the average value is, and then we're going to use val, and that's going to be our local variable. Okay, so the average value is going to be whatever this is, value 1 plus value 2 divided by 2. That's what we're going to output. Okay, because we've got a procedure, because we started a procedure, remember this is pseudocode, so we're going to end the procedure. Okay, but we don't need any of this, okay? But I'm just trying to explain to you what we're going to do. We're going to call the average, okay, 25 to 50, okay? But that is what I'm talking about. 25 and 50 are basically the values, yeah? So that's the answer for 2 marks, but that is what we, in terms of procedure, which sort of links quite nicely to this thing up here, okay, where we're talking about procedures, functions, parameters, local variables. A global variable is basically one that can be used by all of the program, not just that little sort of function. It can be used by many functions. Okay, part C. Outline the role of procedures and functions in creating a program that is easy to maintain. So we remember we're making this modular. Okay, so modular is what I'm going to put first. We're going to make blocks of code and we're going to join them together. Okay, broken into small parts. Okay, small units. The code is reusable. Okay, we can use it again and again. We can use it throughout. We can call that procedure whenever we need to. Reduces, because we're going to reuse it, reduces duplicate. Reduces duplicate code, and I'm just going to put a little side note there, which simplifies debugging, testing. Okay, testing. Okay, so it's modular design, broken into small parts. The code is reusable. It reduces duplicate code, which simplifies debugging and testing. Okay, nice and easy. Now we've got 4 marks. State what is meant by the data types integer and real. So we've got 2. We've got 1 integer and we've got 2 real. Okay, an integer is a whole number. Okay, e.g. 38. And this, a real number, is a decimal or a fractional number. 27.25. Okay, punto. So that's a nice and easy one to get you 4 marks there. Whole number, give an example, a decimal number, 27.25. Any decimal number, any whole number, used for that. Okay, so that's that one over, 1, 2, and 3. Now it gets a little bit more fun. Okay, question 4. The pseudocode algorithm is intended to allow, at random, between 1 and 20 values to be entered and totaled. The total and average is entered. You're right. So question 4. The pseudocode algorithm is intended to allow, at random, between 1 and 20 values to be entered and totaled. The total and average of the entered values are output at the end of the algorithm. So step 1, declare a loop. Okay, it's a string. Okay, well, we're doing numbers, so that's kind of right. Number 2, declare limit as an integer. Okay, good. So I think loop is probably going to be an integer. Declare value as a real number. Declare total as a real number. Okay, total has been assigned the value 0. Limit has been assigned a rounded random value times 19, rounded to no decimal places. Okay, plus 1. If the loop has been assigned 1 to the limit, okay, output enter a number, input loop, total has been assigned total times value, next loop. And then we've got 2 outputs. The total of the numbers entered is total. Okay, and then output the average of the numbers entered is total divided by limit. Okay, well, first of all, this is wrong. Okay, because we're dealing with numbers, we do not need that to be a string. So I'm going to put declare loop. Okay, and we're going to do that as an integer. Okay, because we're going to be dealing with integers. Okay, number 2. So if the loop has been assigned the value, I've never seen that before, if loop. Okay, that would be it. It's a for loop. So 07 for loop. Okay, dot, dot, dot. Error line 3. This is where it gets a bit silly. Okay, then we've got output enter a number, input loop. Well, we're not going to input a loop, are we? How do we input a loop? So 9 must be wrong. We're going to input value. Okay, we're going to input a value because we're using value here, look. Yeah, so that's wrong. Alrighty, next loop, 11. Okay, total has been assigned total times value. That's wrong as well, isn't it? Okay, what we need to do there, yeah, is total plus value. So 9 is wrong, 10, it should be 10. Total, yeah, has been assigned total plus value. Okay, so they're my 4 errors. Yeah. Okay, so we've identified the errors. Line 1, line 7, line 9, and line 10. So now for part B, we need to write the pseudocode statement that would output the average calculated in line 13 of the algorithm rounded to 1 decimal place. Okay, so line 13, output, I'm talking about line 13 here. Yeah, output, the average of the numbers entered is total divided by limit. But we need to round to 1 decimal place. So what I'm going to do is I'm going to take that, pop it in here. Okay. So output. Yeah. The average. And then if I do this, they should sort of understand the average. Yeah, is comma. But then what we're going to do here is put round brackets. So round brackets total divided by limit as before. What we do is put just a little comma in there. Yeah. So total divided by limit, comma 1. Okay, number 1. So that refers to 1 decimal place. Okay, close the bracket. That's it. So output Yeah, same as before, but now we're just going to put brackets, round, brackets, total divided by limit, but do it, comma 1, round, comma 1. Okay? Can I zoom in a little bit on this? Okay, then part C, explain how you should alter the original corrected algorithm to make sure that all the numbers entered are between 1 and 500 inclusively. If any numbers fall outside these limits, a replacement value is requested and entered. You do not need to rewrite the algorithm. Okay, so looking back at it, I wonder if I can revert to this like so. We're going to add some bits in. So at line 8, over here, so let's push this across here. Okay, so 0, 8. Output, enter a number between, enter a number between 1 and 500. Okay, so that's what we do for line 8. For line 9, where it says there, input loop, and we change that if you look down here, yeah, input value, line 10. So I'm going to put a little while loop in here. While value, okay, and we'll do it like this, is less than 1 or value is greater than 500, do, round line 11, do, we'll just put output invalid value. Please, another quote, please enter number between 1 and 500. Okay, line 12, input number. And line 13, finally, yeah, so input number. And line 13, they should have been imported. End while. Okay, so just to try and show you, explain how you should alter the original corrected algorithm to make sure that all the numbers entered are between 1 and 500. If any numbers fall outside these limits, a replacement value is requested and entered. So all I've done is I've changed my input enter a number to enter a number between 1 and 500. Input value is the same, okay. While the value is less than 1 or the value is greater than 500, do output an invalid. Please enter a number between 1 and 500. Okay, just quote marks on that. Input the number and end the while loop. Okay, that's how I would do it. Now for the final bit, write the pseudocode statement to perform this task. Accept the input of a whole number from 1 to 4 inclusive. Use a case statement to output the number 1 to 4 inclusively that was entered. Output the word error if a 1 to 4 inclusive number was not entered. Okay. If we do a case now, there needs to be a top bit for this. Case number of, and then we're going to do 1, 2, 3, 4. Output. Yeah. You enter number 1. So these are how 4 things. Output, you enter number. Okay, output the number 1 to 4 inclusive that was entered. So their output again. Output. Output. And this time, yeah, you entered number 2, 3, and 4. So that would be this case statement, but then we also need, because we've got, well then within this case statement we need another Wise. Just check that that's on. Yeah. Otherwise, output. Yeah. Following this, the error message. Yeah. The word error. And then we end case. Okay, so that's our case statement. Yeah. So that refers to this bit, but then we've got to accept the input of a whole number from 1 to 4 inclusive. All I'm going to do here is just put a little message on output. Yeah. Again, based on this algorithm, just a little message. Please enter a number. Yeah, and I've got on the line between 1 and 4. And then we'll get the user to input number. Okay, so output, please enter a number. Yeah, input the number, and then the case statement number of, yeah, any of those. Okay, case statements. Try and remember this bit. Yeah, okay, that's straightforward, but try and remember, yeah, case and end case, and then wherever. It's choices. It's like a menu system you can see here. It's like a menu system we've created. Okay, but in terms of the menu system, it's just 4 different options, and then like an else and otherwise. Now, okay, wow. Okay, will you be able to see this? Okay, so question 6. The flowchart represents an algorithm. Okay, so we've got a massive flowchart. We've also got, along with a massive flowchart, a massive trace table. Okay, so massive flowchart, massive trace table. Hopefully then, if we've got a massive one of these and a massive one of these, it should be fairly straightforward to fill in. Okay, we've got complete the trace table, yeah, for the input data 7, 47, 50, 52, 60, 80, 63, and 70. Okay, so we'll go through it and we'll see what we can come up with. So start, input limit. Okay, where's limit? Limit must be among these numbers. If, I mean, bear in mind we've got one single digit number, 7, but we've also got 1, 2, 3, 4, 5, 6, 7 double digit numbers. And if we look here, numbers, potentially I would have thought they're going to go in there at some point. Okay, 7 lots of numbers, 7 there, so the limit I'm predicting is 7. Count has been assigned the value 1. Okay, input numbers, count. Okay, so at count position 1, we input numbers. So because there's 7 numbers, I'm guessing that this, the 47, will be our first number. So I'm going to put limit, yeah, in, and I hope I'm right. Yeah, limit in there, number 7. So we've done that one. Yeah, 47, then we'll go in here. Okay. Number, so we've inputted number. Count has been assigned the value count plus 1. Okay, so 2. Is count greater than limit? 2 is not greater than limit. Okay, no. So let's go back and put the next number. So the next number is 50 at position 2. Okay, so position 2 is done. Count has been assigned the value count plus 1, so 3 in there. Okay, is count bigger than limit? No, it's not. So back round, input our number, position 3 is 52. Okay, count is back, count plus 1. Yeah, is count greater than limit? No, it's not. So let's go back round. Okay, number 4 would be 60. Okay, still it's not bigger, but let's do it properly. Input the number, 60. Count is count plus 1, so we're on to count number 5. Okay, is count greater than limit? No, it's not. So let's go back and input number 80. So remember the number, count equals count plus 1, 6. Okay, is count greater than limit? No, it's not. Count is still 7. So back round, input number count. So in position 6, yeah, we've got 63. And then finally, okay, looking at this, final number in the sequence is 70. So let's go, we've inputted number 63, count equals count plus 1, 7. Okay, is count greater than limit? It's still not greater, it's equal to, but it's not greater. So we go back round, okay, and we put in 70. Okay, put in 70. Count equals count plus 1, so that must be 8. Yeah, is count greater than limit? It is now, yeah. Yes, it is. So flag becomes true. Okay, gets assigned the value true. Does flag equal true? Well, yes, it does. So flag gets assigned the value false. Okay, gets assigned the value false, and count gets assigned the value 1. Okay, is count greater than limit minus 1? Well, limit minus 1 would be 6. Yeah, so is 1 greater than 6? No, it's not. So now we're up into this bit. I'm guessing, but I think this bit might be something to do with sorting, because we've got these numbers here, we've put them into these columns here, but here we've got 47, 50, 52, 60, really it should be 63, 70, 80, so 80 needs moving into position 7, and these two need moving up into position 5 and 6. I think we're sorting out some numbers, but we'll see. Okay, so I'm here, I've got to put that marker. Is numbers count, okay, here, is numbers count 47 greater than numbers count plus 1? So is 47 greater than 50? No, it's not. So round to here, count has been assigned the value count plus 1. Okay, so it's 2. Okay, so looking at this, we're going back around. Is count greater than limit minus 1? So is count, I'm going to put a little flag in here, 6, which refers to, let's start that, just so I know in my head what we're talking about. No, it's not. So we're going back round. So is count, looking at this, is the next two. We're compared 1 and 2, so it's like bubble sort. Then we're going to compare 2 and 3. Yeah, no, it's not again. So we're going to go back round, 3. Yeah, at position 3. So we go back round looking at this until we get to position 5. So back round 4. Okay. And then when we come finally around to position 5, yeah, is count greater than limit minus 1? Well, no, it's because we're still talking about 6. But is number in count at position 5, yeah, is number in count at position 5 greater, yeah, than the number in count plus 1? Well, yeah, here, this is bigger, yeah, than this one here. So swap becomes numbers in count. Okay, so we're swapping, looking at this, at position 5, we're going to put in position 5, yeah, here, I'm going to put a swap value of 80. Okay, I've put in a swap value there of 80. So I think we need to swap position 5 and position 6. So let's have a look. Number count has been assigned a value, number count plus 1. Okay, so this one I'm going to start another row because so it makes sense to me. Okay, so I've swapped, yeah, that with that. Number count plus 1 has been assigned a value swap. So swap is 80. Number plus 5 plus 1 is 6. So 80 must go in there. Flag then becomes true. Okay, so we've sorted out these two numbers. These two numbers here have been swapped around. So count becomes count plus 1. So let's put a 6 in there. So is count greater than limit minus 1? Is 6 greater than 6? No, it's not. So back up here, is 80 bigger than count plus 1, bigger than 70? Yes, it is. So we're going to put a swap in here. So swap, again, 80. Okay, because we're going to be swapping 80 from position 6, which it is now, into position 7. My word, I know. It's a little bit complicated, isn't it? A little bit complicated. So, where are we? So we swapped. Yeah, swap. Yeah, has been assigned the value number in count, 80. Numbers count gets assigned. So it gets assigned the value number count. So in here, that should be, just so I'm leaving a bit of a gap like I did before. Number count plus 1, so the swap value goes into, the swap value here goes into that position there, so 80 goes in there. Okay, then what happens? Flag becomes true again. Yeah? Okay, so flag becomes true. Coming down, count becomes count plus 1. Okay, so let's put that there, 7. Okay, is count greater than limit minus 1? So is 7 greater than 6? Yes, it is this time. Okay, yes, it is. So back up here, okay, so here, is flag equaling true? Yes, it is. Okay, flag gets assigned the value false. Okay, flag gets assigned the value false. Assign the value false, yeah. And then count becomes 1. Okay, is count greater than limit minus 1? No, it's not, because that's going to be 6 again. So where do we go? No, so up here. So I think this is a check. Is number in count, this first position here, count 1, is this bigger than? Okay, is it bigger than? Well, no, it's not. Okay, it's not bigger than. 47 is not bigger than 50. So no, so go back around. Count equals count plus 1, 2. My word, no. Okay, background. So we're going to be going, looking at this, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, until we get to 7. Okay, so we've gone round and round and round until we get to 7. Is count greater than limit minus 1? Yes, it is now. Okay, so yes, it is. So up here, is flag equal to true? No, it's not. It's false. So we're going up here to this bit. Okay, so we're at position 7. Yeah. Result equals, hang on, we're on to result now. Result equals limit divided by 2 plus 1. Well, remember, we don't do remainders or anything in this. So 7 divided by 2 would be 3. Okay, 3 plus 1 would be 4. So that answer there would be 4. Okay, output numbers result. Okay, output numbers result. So let's have a go. I'm just going to come down. I'll do it on this one. Result would equal 4 in that column there. Then what else do we need to do? But output numbers result. So position 4. Yeah. Result is 4. Output position would be 60. So that position there would be 60. Good. I didn't enjoy that one. It's a lot to do, a lot of repetition, as you can see here. But basically, it's 7 marks, so I'm assuming they're wanting 1 mark for this, 1 mark for this, 1 mark for all the numbers. So 1, 2, 3 marks, 4, 5, 6, 7. Okay, that's what I would think, that's what I would expect them wanting to do. Horrid question, horrid question. Okay, here we go. Outline the process involved in the algorithm showing the flowchart on page 6. Well, basically, it's a bubble sort. You've got a set of numbers are inputted. That's what I did. I inputted them, yeah, and stored in an array. Okay, so that's one thing I did. What else did I do? That was the first step in the process. The numbers are sorted. Okay, I would put in here bubble, because we're comparing pairs, so it's going to be some kind of a bubble sort. Okay, and then 3. So we found the 4, didn't we? So the middle median, median is found. Okay, that will do. Outline white is useful to store data in a file. Oh my word, okay. Well, it will provide a permanent copy stored in secondary storage. Okay, generally. So provide a permanent copy would be 1, could be transferred, sent across a network. Okay, I think I'll get my IB head on there. So yeah, provides permanent copy stored in secondary storage, could be transferred, sent across a network. Okay, now this one is for 4 marks. The function length x, yeah, calculates the length of a string x. Write the pseudocode statement, read the contents of the text file, quotation not text, into an appropriate string variable that has been declared. Output the string in uppercase and the length of the string. Okay, so because we're doing pseudocode and because it says all the words for this question are hidden in the question, okay, you've just got to know a little bit about pseudocode and what to do. So especially if you've attempted those sort of big questions at the end of past papers. So we're going to first of all declare, okay, I'm not really worried about capital letters or anything at this moment in time. But I'm going to declare the quote string, I'm going to call it quote string, yeah, as a string. Okay, that's the first job. I'm going to declare quote string, that's going to be a variable, as a string variable. And then I'm going to open, I'll do this in capitals, open file. Okay, what file am I opening? I'm opening file quotation.text. Okay, what do I want to do with it? For read. Okay, I don't want to write to it yet. I just want to open file quotation.text for reading. Okay, but then, so based on that, I'm going to read file. Okay, what am I going to read? Again, I'm going to read quotation .text. I'm going to read the file quotation.text. Read to where? I'm going to read it into this quote string I've created. So I'm going to read for into quote string. Okay, the variable I've created quote string. Okay. Once I've opened it, I've read it into my variable quote string, and then I'm going to close the file. Okay, because I've read it into this now. It's now taken that text, put it into my variable. So I'm going to close file. What are you going to close? I'm going to close the file quotation.text. Okay, so what do I do then? I've read the contents of the text file quotation into an appropriate string variable, okay, which I've called quote string. And I've declared, yes, I've done all that. That's that. But now, output the string in uppercase and the length of the string. 2 parts. Output, yeah, or display. It depends on, I don't know whether they accept it in GCSE. At IB, you could use display. But output, and I'm going to put, and you could put output.upper, but I'm going to use, or ucase, but I'm going to do it uppercase. Okay, but you could use, I know I've seen this on papers, UCase. Okay, there. So output uppercase, and I'm going to uppercase, what am I going to uppercase? Quote string. Okay, my variable, my string variable. So output uppercase quote string, and then I'm going to output with an appropriate message. Okay, output again, the length of the string, yeah, is dot dot dash comma length, yeah, and then in brackets quote string. Okay, so there we go. So I'm declaring a variable, give any name you want as long as it makes sense, yeah, as a string. Open the file, read the file, close the file, output it in uppercase. Output what in uppercase? The quote string. Output the length of the string, a little message is length quote string. Okay, it's if you don't know it, it's quite daunting, but yeah, nice, easy steps. Okay, next one. Again, question 8, don't be fooled by this. Consider the logic expression. Z equals R or not T, X or not S and T. Okay, do this one first. Okay, because you've got two sections here, 1, 2, and 3. Okay, 3 is the one nearest to the X, or sorry, in this case, the Z. So it's an XOR gate, so I'm going to go here, I'm going to draw my little sort of sail, but it looks like that. Okay, with 2 lines coming off it. That is my XOR gate. Okay, tick. That's it. Now then, R or not T. So we're working with this one and this one. Okay, and then here we've got S and T. Okay, so let's do this one first. Not S. So let's put a NOT gate in. Okay, not S and T. So we're going to put an AND in there. That can go to the AND, and the T can go to the AND, and that can join up to that. Okay, so that's not S and T. Done. Now this side, we've got R and not T, R or not T, so I'm going to put an OR gate in. Okay, and that can go directly to this. Yeah, R can go directly to this. Yeah, but T, it says not T, so from here, put a little bridge over the top. Yeah, so T is going to go to that, but T, as you can see, has got a NOT gate in it, so let's just put that in there like so. Okay, so hopefully that makes sense. We've got, if we count the gates, we've got an OR gate, tick, a NOT gate, so OR gate, NOT gate, XOR gate, NOT gate, and AND gate. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, we need to know what the truth table is for an XOR gate, otherwise we're going to be struggling. So, if I come up here, and I just put a little, just as a reminder, yeah. So, A, B, X, and it would be 0, 0, 0, 1, 1, 0, 1, 1. An XOR gate means an absolute OR, nothing else, not AND like a normal OR gate, so that would be 0. These two would be on, and that would be 0. That's how an XOR gate works. So we've got to bear that in mind. And I'm going to put in, okay, working space, great working space. RST, I'm going to put T, I'm going to put U, V, W, X. Okay, so everything at V will be the opposite of S. Everything at U will be the opposite of T. And then we can combine U and R to get W, and we can combine T and V to get X. So I'm going to split this into 4 parts. Okay, like so. And I'm going to put my first one as being U, which is U, which is not, yeah, U is not, okay, so U is not T. So T, so the opposite of T, 1, 0, 1, 0, 1, 0, 1, 0. Okay, now V is not S. Not S. So looking down here, 1, 1, 0, 0, 1, 1, 0, 0. Okay, W, yeah, is, so U and R, U or R. Okay, so U, oh, that's a V, but U, okay, U or R. So here, 0 and 1, so that will be okay. 0 and 0, no. 0 and 1, yes. 0 and 0, no. 1 and 1, yes. 1 and 0, yes. 1 and 1, yes. 1 and 0, yes. Okay, and then finally X, which would be V and T. Okay, V, so it's got to be both, have got to be turned on. So V and T. Yeah, so X, yeah, V, this one here, and T. So both that one and that one have got to be turned on. So no, that's okay. No. 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 Yes. No. No. Okay. Now, going back to the XOR gate, remember, it's got to be either 0 and 1 to give us a 1, or 1 and 0 to give us a 1, or 2 zeros is an off, and 2 ones is an off. Okay? So, W and X, yeah? W in here, X in here. So, we've got swaps. 1, 1, 1, no, yes, no, yes, yes. Okay, so that would be the answer there. This is why this paper is 1 hour, 45 minutes. Yeah, you got a 4-mark question, well, 9-mark question here. Yeah, on here we had what, 4, 5, 6, 7, 8, 9 again on that one. So yeah, big questions. Okay, but that's the end of that one. So we've got the final one. Okay, a database table called soft drinks. Yeah, soft drinks. Yeah, stores details of soft drinks sold in a small shop. Cola, yeah, from Cambridge Beverages. It comes in a can. It's 330 milliliters. Number in stock, there's 30 of those cans have come in. Reorder level, when the stock gets down to 15, then we order some more. When there's half the stock left and reordered, it has been reordered. Okay, so we've got a Boolean, we've got some numeric values. Okay, good. What I can't see there is any indication of a primary key. Okay, state whether any of the given fields would be suitable as a primary key and give a reason for your answer. So I'm going to put no. And I'm going to put nothing has the potential to be unique. Okay, there's no unique field in there. Okay, they might only have one supplier of cola, but Cambridge Beverages might supply lots of different drinks. Okay, that could, you could argue cola could be one, but as I say, maybe not just Cambridge Beverages, other beverage companies like Coca-Cola, yeah, supply cola. Okay, complete the structured query SQL statement to return the number of cans the shop has in stock. Okay, so select, so we could do this from Let's do from soft drinks. So that's an easy one. That gets us 1 mark straight away. We're doing always from the table that it's coming from. Where what? Complete the structured query language SQL statement to return the number of cans the shop has in stock. So I'm going to select, I'm going to do a sum, okay? Sum of what? I'm going to do a sum of number, so I'm going to do a total, number in stock, okay? From soft drinks, where the container equals, see here, number of cans. So number in stock, so I'm using number and I'm using can. Okay, so that should get us 1, 2, 3, 4, 5 marks. Yeah, excuse my writing, but that is it. That is the first part of this paper. I do want to spend some time and go through for the complex question at the end. Okay, thank you very much indeed. See you next time. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.